This question is going to say something like, here's a quadratic, right? You can see it's written in the form y equals ax squared plus bx plus c, right? It's written in standard form. And what I want you guys to do is take it, written in standard form, and switch it to factored form so that I can do the work from this morning, right? That's all I'm going to ask you to do. I just wanted to do a couple questions that we can like run through like in its entirety, right? So right now, I know from this, the thing I know, the y-intercept, I know the y-intercept has to be 16. And that's because we said it was the c value. That's the only thing I know, aside from the fact that it's opening up because it's positive out front, right? That's all I know. So I can't produce a graph based on that information, just one point, right? Like I know the y-intercept is 16, and that's it, right? So what you're going to have to do is switch this into the form that we worked with this morning so that we can actually figure out what it looks like, right? So we just take our skills from the other day, say, okay, I need two numbers that multiply to, add to, and then we start running to try and figure out the numbers, right? So we need two numbers that multiply to 16 and add to 8. Why did I put it in that order? Because when I spell the word man, the A is always in the middle. So you put the A in the middle. Okay? And then you say, all right, multiply to 16, add to 8. Right? So let's just start trying some numbers. I don't know. Let's try 1 and 16. 1 times 16, that equals 16. Good. 1 plus 16 is 17. That doesn't work for that one. Okay, let's do the next one. Bailey's saying 4. I don't know yet. 2 times 8. 2 times 8 equals 16. But 2 plus 8 is not 8. It's 10. All right, so that one doesn't work either. The next one, 3 doesn't go into 16. Not going to work. 4. 4 times what, Bailey, equals? Hey, 4 and 4. Okay, so 4 and 4. Oh, that's not a point. 4 and 4 are the two numbers. They work. They check out to 8. Now, what we're able to do now for this particular question is you can say, you take whatever the variable is, and you write it out front of the two numbers. So this turns into x plus 4 times x plus 4 equals 0. Okay, this is an interesting question. I probably shouldn't have picked this one right off the top, but it's an interesting one. So let me ask you guys now that there's 4 of you here, what are my x-intercepts? Like if I went to go produce this graph, I'll draw it like this. Okay, if I went to go draw this graph, where are my x-intercepts? All right, by looking at this equation. Okay, both. Interesting, Bailey. Both. Bailey's saying both of them, right? If I look at this, well, it's positive 4 and positive 4 there. Bailey's saying there's both. Both x-intercepts lie at negative 4, 0, right? So we're going to say, well, how can that be? X-intercepts. We're going to write this twice? How are we going to do that? We're going to go plot them? All right, well, let's count maybe each box, for instance, right? Each box might be worth 2, okay? Each grid. So we'll say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So my question, okay, well, how am I going to plot 2 of the same thing? That doesn't make any sense. I only have one x-intercept for this one. Where is it? It's at negative 2, negative 4, negative 6, negative 8, negative 10, Negative 12. This is an interesting question. So I had to go plot my point, right? I only have one. Negative 4, 0, right? And that's it. Where's that point? Right here. Now the challenge with this question is, how on earth am I going to produce this graph? Well, we also said in the initial part, don't forget, like sometimes you need to use all the information available to you, right? We said our y-intercept, which we found from standard form, was at 16. All right. So here's the problem. Because I only have one, and I know this is a hard question, but because I know this, this is actually our vertex for this question. It's a unique situation where we only have one x-intercept, right? This makes this the vertex, which then means if that's the vertex, then this is our axis of symmetry, which then means, okay, well, I count 1, 2 boxes out to the right, so I'm going to count 1, 2 boxes out to the left. And there is your parabola, where you only have one x-intercept. Anybody have any questions? That's a hard question, okay? Hopefully the ones we do in a minute are going to be a little bit more related to this morning stuff. But anyway, this is, as a whole package, exactly what we need to do, like where our end product is. Okay. So if we can do this, this is like, you can't make it any harder aside from what the academic kids are doing. Okay. Okay, and that, the only way to make it harder is to give you a harder question initially. Right? Other than that, you're both responsible for the exact same work in order to produce these graphs like this. Anybody have any questions? Okay, I'll jump down and I'll do the two that you guys wanted to do, 3A and 3E, okay? Because why I like 3A and 3E and why we're doing this right now is like I can pull in multiple things that we've done over the last few days, right? And tie it together as this big, nice package with a little bow on top, right? Like this is the end product. Can you do this, right? Can you produce this graph? That's what I need you to do, okay? So you take your skills and build towards it, okay? So I'm going to scroll down. Okay, now I'm going to go to what you guys wanted, 3A. So I'm just going to copy this question out here, okay? 3A. What did I say? Oh, I didn't even pay x. 3x squared plus 24x. $45. All right, so there's this thing that we need to do, right? When we see a question like this, and I'd imagine you guys picked this because you don't know what to do here, right? I would say there's something you can do, and it's called greatest common factor, right? So when I'm trying to find the greatest common factor, I'm looking at all three pieces here, right? 1, 2, and 3. All three pieces. Okay. What is common across all three of those pieces? Anybody tell me in the chat? Right? So remember, we're trying to build our greatest common factor, right? Bailey's, right? We got 3, right? Is there any variable, Bailey? Do I have to take like a 3x or do I have to take no x's, right? Because there's no x sitting here. I can't do anything with that, right? So I can't remove an x, but I can remove the 3, right? So this is my greatest common factor. Now in the next line here, I want you guys to write down for me what's left after I remove this 3. Well, we're going to get 3 out front, and then you tell me what's left. 3 divided by 3 is 1. So you get an x squared. 24 divided by 3 is going to be 8x. And 45 divided by 3 is what? $15, right? Hey, there you go. Okay. So now you have something that looks workable, right? Good. Okay. So here's what we got. What can I do here? You can apply your man process. All right. Multiply to 15, add to 8. What are the two numbers that work for that? You need two numbers that multiply to 15 and add to 8. You could start. All right. Some of you are savvy enough to get it right away. Okay. I can see 3 and 5. 3 and 5 work, right? One number is 3, the other number is 5. When you multiply 3 and 5 together, you get 15. And when you add them, you also get 8. Okay. So then I come down here and you say 3 times, what do? We put the variable in front of the two numbers. X plus 3 times x plus 5. Now I hope this looks somewhat familiar to you. Right? Is this something that we did this morning? So remember what we're doing, I'm asking you to produce the graph of this. I'm asking you to produce the graph of this equation up top. Graph this, I'll say. Right? And you're like, oh, okay, no problem. Well, I can factor out, I can remove the 3, and then I can produce it to something that looks like this that I know what to work with or how to work with. And now that you guys are at this stage, you can answer information or questions about what the x-intercepts are. What are the x-intercepts? You guys know what the x-intercepts are? Remember, they're just the opposite of this, whatever number you see there. So one of the x-intercepts is going to be at -3 and 0. Hey, good. Sometimes I don't know how long it takes for you guys to type things. I don't know. It's tough for me to see. -5 and 0. Those are your two x-intercepts. These are important pieces of information. We can use that now. Right? So you go, okay, no problem. Now I know my x-intercepts. Let's go down here. Let's draw a little graph. Now I have the luxury of having some grid paper here. But I also have the ability to draw perfect straight lines, which helps. Okay, let's plot those points. So we'll treat each one like 1. Okay, -1, -2, -3, -4, -5, -6, -7, -8. Okay, you guys say, okay, let's go plot those points. These two here, these are your x-intercepts, where they cross the x-axis. So we say, okay, -3, 0, and -5, 0. Okay, so there are your x-intercepts. Now your next question is, where's your axis of symmetry? Where's the axis of symmetry? Well, the axis of symmetry has to be in between these 2 points, right? Has to split them down the middle, right? So Bailey's right at -4, right? Caesar's right. You draw your axis of symmetry. Make sure you label it. X equals -4, right? So x equals -4 is the axis of symmetry. Then from there, you're like, your final thing that you have to do is to figure out, okay, well, where is my vertex, right? Well, you know the vertex has to have an x piece of -4, right? Because it has to be somewhere along this red line here, which means it has to have an x value of -4. Right? So you're like, okay, well, let's you could plug x equals -4 into here, or you could plug it into here and here, or you could plug it into here or here. Remember, all three of these things, numbers 1, 2, and number 3, they're all the exact same graph, right? They're just written in a different way so that you can see different information. How did we do that? Factoring. That's how we did it. Okay? So you plug in -4 into one of those three equations. Which one would I pick? I'd pick this one because I think it looks the easiest. Right? So I'm going to take -4. I'm going to plug it into that equation. 3, and remember it's y equals 3 times -4 plus 3 times -4 plus 5. Right? And so that's going to be equal to 3 times -1 times 1. Right? So 1 times -1 is -1. -3. So what's your vertex? -4, -3. Where did the -3 come from? After you plugged it in. So you go plot that point. That's your vertex. Question's over. You just connect the dots after, right? You go -4, -3. Here's your vertex, and here's your graph. Done. You guys have any questions? Ariel, I can do 3E if you guys like. Okay, maybe a good practice for you guys to do, maybe I'll post that, is that you guys take the questions from 3E and just do the graphs for them. Okay, I don't mind doing 3. I can do one more and then we can call it, okay? I just gotta find 3E. What does 3E say? Okay, we can do 3. That's a good question, Ariel. So let's take 6x squared plus 24x minus 30. I know you guys can't see my screen. I'm just copying it down. Okay. And again, the question is going to say, graph this for me. All right. So I don't like the look of this question right off the top, right? Like, multiply to 30, add the 20. Those are big numbers, right? Like, I want to make it smaller. Let's make it smaller. Okay, how can I make this look smaller? Find the greatest common factor. What is the greatest common factor amongst all three of those? I think they're all divisible by 6. Yeah, right? I think they're all divisible by 6. So your greatest common factor is 6. Right? So let's just remove the 6 then and tell me what's left. 6. What's left? X squared plus 4x minus 5. Right? Are we okay? Now, if you want to figure out what the remember, this is, maybe we'll have a different conversation here. This is your equation, right? Just change the form. Still y equals up here. Now, when we're interested in the x-intercept specifically, it's where it crosses the x-axis. What is the y value at these 2 points? They're both 0, right? Right? So when both y values are 0, I'm interested in these 2 points, right? So I'm going to replace y with 0, right? And this is where this comes from. When I'm solving for the x-intercepts, I'm saying 0 equals 6x squared plus 4x minus 5. And now I'm going to make this simpler so that I can find what the x-intercepts are, right? I'm going to say find x-intercepts, right? How do we do that? Factor. All right, so we're going to need two numbers that multiply to -5, add to 4. It's a little bit harder, right? Anybody know what the two numbers are? I'll wait for you guys to do this one because this is an interesting one. Okay, I need two numbers that multiply to -5 but add to 4. Okay, Cam, no worries. I'll upload this anyway, Cam, okay? No worries. Okay, Bailey's saying -5 and 1. Okay, so that's... Now, Bailey, when you write these things, that looks like, if I was to go plot that, that looks like a point to me, okay? So try to stay away from -5, -1, Bailey, might be like look like this. Okay, that's not... We want to avoid writing this. Okay, or sorry, 1, whatever it is. Okay, because that looks like a coordinate point that I can go plot. You want to just like, don't include the brackets, I suppose is my thing there, Bailey. Okay. So you can just say the two numbers are -5 and 1. Right, so that works. So then we come down here and we say, okay, 6, and then x minus 5 times x plus 1 equals 0. Right? What are the two x values, or the x-intercepts? Well, one of them is going to be x equals 5 and x equals -1. So what are the points with that? 5 and 0 and -1 and 0. There are your x-intercepts. Where's 5, 0? 1, 2, 3, 4, 5. And -1, 0. There are the 2 points. Now your next job is to, where's the axis of symmetry? Well, axis of symmetry is right in the middle of those 2 points. 1, 2, 3, 4, 5, 6. What's in the middle of those? 3. So count 3. 1, 2, 3. Here is your axis of symmetry. All right. At x equals 3. How do I find the vertex? I would use this equation, right? Because I think it's the easiest of the 3 that we've written down. And you say, okay, you're gonna plug x equals 3 in there, right? Where, you might ask? Plug x equals 3 into the x's, right? We find a y value. So y is equal to 6 times 3 minus 5 times 3 plus 1. 6 times -2 times 4. Oh my goodness, is this right? It's a big number. Might not fit. So sometimes these questions aren't meant to be graphed. Your questions on your tests will be meant to graph, right? But sometimes these aren't meant to graph. So if we look at this, right? I think we're going to get 48 here, -48. Right? And so, because we get 6 times -8, which is going to be -54. What is it? 36? 36 and 54. 54? 54, sorry. That was one off. No, I was right. I was right. I was right. So this is like in a normal classroom, somebody would correct me. I was right in the first place. 48. 54 is one more. That's 9. 9 is 54. Okay? So 48, guys, is going to be like, depending on how you choose to do your thing, like count. Like you could count by 2s. That's no problem. -2, -4, -6, -8. You could do that. Regardless, you're going to end up way down here somewhere for this point, right? Because the vertex now is going to be at 3 and -48. Well, negative 48 is way down here. So your graph's going to look something like this. So sometimes these questions aren't meant to be graphed. I'll make sure the ones I put on formatives and things like that are like that they'll actually fit on the grid that I give you on the page, okay? But that you can do this to anything you want. It's just it gets bigger and bigger, right? That's all. Bigger or small. Anybody have any questions? Okay. So what I'll do is I'll post this. I'll hit stop.